All right, the second part of 4.6 is about finding potential zeros and then how to find out if they really are zeros or not. So this first example, here's what we do every time. You start with the last number. You write it down and you write all of its factors. The only factors of 1 are 1, so that's it. Then you find the first number and you find all of its factors. The factors of 2 are 1 and 2. And then we make all the possible fractions that we can from this list of numbers. So I can go 1 over 1, 1 over 2, that's the whole list. But for each one, we do both the positive and the negative versions. Let's do it again over here. So this time, I start with the back always. I do the factors of 1, that's just 1. The factors of 3, that's 1 and 3. That's all the things that go into 3, and I make all my possible fractions. 1 over 1, 1 over 3. That's my possible fractions, the positive and negative version of each one. It turns out this is the whole list of all the things that could be one of the factors of this. So we've made the whole list. Now we just have to test if they really are or not, because this again is a list of potential real factors. So here's how we test them with something called synthetic division. So I'm going to test positive 1, negative 1, positive 1/2 and negative 1/2, and that's what I've done here. I'm not going to go through them all, but I am going to give you this so you can see them all. So here's what I do first. I put all the coefficients. The coefficient of 2 to the 6th. Now I have to carefully make sure I don't miss any. To the 5th. Well, there isn't one, so I put a 0. To the 4th. There isn't one, so I put a 0. To the 3rd. There isn't one, so I put a 0. To the 2nd. Oh, that was a negative 3. To the 1st. That's a negative 1 because there's that imaginary 1 floating there. And then the final number is 1. So I just list them all out. And then I did it 4 times because I know I'm going to test all 1, 2, 3, 4 of these. Now, to test the 1, here's what we do. It's easy, but we have to do it a bunch of times so it gets boring. I put the 1 that I'm going to test right in this little box. I drop the 2 straight down. 2 times 1 is 2. Add. 0 plus 2 is 2. Now multiply. 2 times 1 is 2. Now add. 2 times 1 is 2. Add. 0 plus 2 is 2. Now multiply. 2 times the 1 over there is 2. Add. Negative 1 times 1 is negative 1. Add. Negative 2 times 1 is negative 2. Add. Because the answer I get in this last slot will not be 0, then this is not a factor. I did the same thing for the negative 1. You bring the first one straight down. Then multiply what you get down here on the bottom. You multiply that by the number in the box, so negative 2. Then you add it. Multiply by the number in the box. Add. Multiply by the number in the box. 2 times negative 1 is negative 2. Add. You do it over and over again. It turns out none of these are factors. So that was not my best example. But if I look here, I've done another one where I found one that is, so you can see what that looks like. So first I'm going to make my list of potential zeros. The last number is 16. So its possibilities are 1, 2, 4, 8, and 16. That's all the numbers that go into 16. The number in the front is a 1. Its only factor is itself. I make all the possible fractions. 1 over 1, 2 over 1, 4 over 1, 8 over 1, and 16 over 1. Sometimes there's a lot more than this. And you have to do the positive and negative version of each one. You test them all. Remember how we test them with that synthetic division. So I take the coefficient of to the 6th, to the 5th, there isn't one, to the 4th, to the 3rd, there isn't one, to the 2nd, to the 1st, there isn't one, and then the final number goes here. Here's how we test it. Remember, drop that first number down. I get a 1 and I multiply it by the number in the box. That's 4. 0 plus 4 is 4. 4 times 4 is 16. Add.
No, he wasn't.
Add. 0 times the 4 is 0. I add. 1 times the 4 gives me the 4. Add. 4 times the 4 is 16. This time we do get a 0 in this final box, and that means no remainder, which means yes, it was a factor. How many are we looking for total? That power right there. So there will be 6 of them total. I found 2 of them here just to show you how it works. But again, total there will be 6, but they might not all be real. So we might find less than 6, we won't find more. In this example, again, there might be up to 6, but they must all be imaginary because we tested all of these and we didn't get any of them that worked. Again, here there's a potential that there's 4 of them, but when we tested all 4, none of them worked. So the 4 zeros must all be imaginary.